Hello everyone, and in this series of lectures we'll discuss about the important topic uh, that is module 5 by V2 syllabus, and that is Laplace transformation. So in this series we'll discuss about the definitions and properties based problems based on the best problems, and then transform of some special functions, convolution theorems, Laplace inverse transformations, and then we'll discuss finally about the solution of differential equations which we studied already in the module 2 and module 1 by using the Laplace transformation. We'll discuss here by using the Laplace transformation. So this 5 important topic is there in this lectures, and it will cover you 16 marks for the final examinations. So now we'll do one by one what is Laplace transformations, and one by one we'll discuss about its properties and all the problems. So now first here, what is Laplace transform? Laplace transform. So Laplace transformation is used to convert time signal to frequency signal. Okay, so if time is given t here, so we'll convert in the frequency signal, and that is what by using the operator called Laplace transform. Okay, so here if you want to find frequency signal to time signal, then you have to do Laplace inverse transform. So how will you do that? So if f of t is real valued function means that Laplace transformation is bounded if t is greater than or equal to 0. So if f of t is a real valued function, then Laplace transform is defined as L of f of t, and that formula is integral of 0 to infinity e to the power of minus st into f of t dt. Okay, so here f of t is which one function you want to find the Laplace transformation. Like consider example, you want to find the Laplace transformation of t square. So this is your f of t. Just you have to substitute in this formula 0 to infinity e to the power of minus st, and f of t is here t square and dt. So here you have to apply the integration by parts, here also called as Bernoulli's equation integrations, and you have to simplify. So many students getting the doubts in finding the u into v, that integrations. We'll do some problems here first based on u into v. So consider before the starting the Laplace, we'll discuss about the u integral v. The students who already know these integrations, Bernoulli's integrations, they can skip these properties. See, if u into v given, so formula is u integral of v minus u dash v double integration plus u double dash v triple integrations minus, and so on it will go. So here how will you remember? Here you keep as it is only in the small bracket, v you write as a big bracket. Similarly u dash, which one is there? U differentiate one times. V which is given in the big bracket, square bracket, you can integrate once again, then it will become a double integration. Similarly here this u again you differentiate and v triple integration, so on it will go. And you have to keep in mind this islet. Based on this you have to choose which is u, which is v. This I extend for inverse trigonometric functions. L is logarithmic function, A is algebraic functions, T is trigonometric functions, and E is exponential function. So based on this we have to choose which comes first, that is your u. Like consider example I have taken here, integral of x square sine of 2x dx. So here x square is algebraic functions and sine 2x is your trigonometric functions. So algebraic comes first, then it's come trigonometry. So you will consider as a x square and I will consider sine 2x as a v. So we can find it like that. Integration, you keep as it is only x square sine 2x integration. Sine 2x integration is minus cos of 2x by 2 minus s square differentiation. This one differentiate one times you do it, so it will become your 2x. Which one is there in the square bracket? Integrate once, means minus cos 2x by 2 have to integrate. So minus 1 by 2 is your constant outside, and cos 2x integration is sine 2x by 2 plus, again which is there in the small bracket, again differentiate 2. Then here integration of these terms. So minus 1 by 4 is constant here, and sine 2x integration I already know minus cos 2x. So minus minus become plus, and cos 2x by 2. Again minus, sign alternate, plus minus plus minus. So now again if I will differentiate, this 2 differentiation is 0. So now 0 into anything is 0. So you have to not go further till here is what your integrations. Now you can put the limit. If you given limit here 0 to pi by 2, yeah, infinity, you can substitute your limit. Likewise, if another example we'll see, we'll see another example here. If you given e to the power of 3x into sine of bx dx, here sine of 2x something is there, sine of 2x. So see here in this, if you consider as a islet, this is exponential function, this is trigonometric function. Trigonometric function come first, then exponential function. This is u, this is v. But when you start differentiating u, this sine 2x never stops. It will never stop. You will keep differentiating. Sine 2x become cos, cos become sine. Again it will come keep differentiating here. So here we will not apply u into v. We directly derive formula. I will tell you to remember here, e to the power x sine of bx dx, e to the power of ax by a square plus b square, a sine of bx minus b cos of bx. This one directly formula you can remember. Similarly, e to the power of ax cos of bx given, so you can remember the formula directly here, e to the power ax a square plus b square, a cos of bx plus b sine of bx. Okay students, so here if you consider given integration here, e to the power 3x into sine of 2x to integrate. So here you can assume here a is your 3 and b is your 2, and directly you can write here e to the power of 3x by 2 square plus 3 square plus 2 square, 9 plus 4 13, a 3 into sine of bx 2x minus 2 into cos of 2x. This is direct integration. So this is all properties you have to keep in mind. If you don't know this, you have to practice it, and then we'll come further, we'll go to the Laplace. So now here Laplace transformation we are discussing. If f of t is a real value function, then Laplace is defined as 0 to infinity e to the power of minus st f of t dt. Okay, so here if any function is given, just you have to substitute it here and you have to find the Laplace. You have to find the integration, and that's represented as a bar of this. Okay students, so now we will discuss about some function. Like consider if you given find the Laplace of sine of 3t. So we will do it here how? 0 to infinity e to the power of minus st, f of t is here sine of 3t dt. So e to the power at sine of bt formula already have discussed, e to the power at by a square plus b square, a sine of bt minus s into sine of 3t plus b cos of bt 3 cos of 3t. This is the your integration, and you have to substitute where to where, 0 to infinity. Whenever the infinity is there, the e to the power of minus st become your 0. S square plus a square, your constant we take outside. This is 0 here. Minus 0, if you put e to the power 0 is 1. Here this term is what completely 0. And it cos, if you put here t is equal to 0, then this become your 1. It will become here 3. Okay. 0 minus minus 3 become plus 3. So you can write here 3 by x square plus a square. A is just, I can substitute it, a is what 3 here. So s square plus 9. So this is the formula for the sine of 3t. So all the problems you can derive by using Laplace. Yeah, already you can find by the problem. So now we'll see here